Okay, so after all of those technical difficulties, we're gonna start in about 2 minutes. Presentation is relatively short. We'll just have a shorter Q&A because of all these difficulties. Um, I would prefer if everyone could just keep themselves muted. You can have your video on if you want. Yeah, I'll start sharing my screen at 7:30. Okay, so it is now 7:30, so I think we can get started. So I think to introduce myself, my name is Shashank Sastry. Um, Obviously, I'm teaching you guys today about neural networks in general. Specifically, we're going to be talking about just basic neural networks, and then we're going to be going to sort of convolutional neural networks that do a lot more analysis than your average basic neural network. And I'm going to give you 2 examples today of how you can apply neural networks. One is going to be on your own home computer, and another one's going to be you're going to need a lot more powerful hardware to run the other example I'm going to show you. So let's jump right in. I've created a little presentation that we can follow along with. So I just share my screen real quick. Okay, so, all right. All right. So could everyone just react with like a thumbs up if you can hear me okay and see everything on my screen? Like if you guys know how to react, like, or not. Okay. In any case, we're gonna get started now. So neural networks, a layman's guide. I'm Shashank Sastry, who's going to be teaching this. So let's specifically talk about what are neural networks. So let's look at the Wikipedia definition first. So neural networks or connection systems are computing systems vaguely inspired by biological neural networks that constitute animal brains. Like data structures and functionality in neural nets are designed to simulate associative memory. So TLDR, basically neural networks are just algorithms that allow us to use computers to classify patterns in like general structure with a sort of human nature. Let's look at some applications, right? So it may seem like neural networks are like super advanced and like really like you don't interact with them on a daily basis. They're used for like really high level stuff, but actually you do. So I think first off, like if we look to something like WWDC 2020, we saw that with iPadOS 14 and the Apple Pencil, we got handwriting recognition that uses neural networks to basically track like different handwriting styles. But in general, it can find a pattern of general like scribbles and things that you would write with your Apple Pencil on your iPad in a text field, and it just transcribes it straight into raw text in like a font. Um, Say another example, we see it in stock market prediction. So neural networks are actually used in unmanned training by a company called Citadel Securities, where there's literally guys sitting in like offices, just basically looking over. They're basically just supervising computers that are automatically trading stocks using neural networks and watching patterns of the market, basically. Um, I'd say another good example here would be image segmentation. Now, this is something I specifically worked on as a data science intern at NYU. Um, Image segmentation is something that's really good to apply neural networks to. So in my case, we applied in conjunction with AlexaPath, which is a neural network company. We created a smart microscope that can screen for cervical cancer, and as I'm about to show you, we can also screen for Alzheimer's disease, and we can also classify cities. It's pretty cool. Um, as well, there's also text classification as one of the applications of a neural network. So when you look at Google's fresh content algorithm, where if you listen to Sundar Pichai talking about Google, especially in those reviews, right, that are super awkward, like when we see that, it's constantly this talk about fresh content, and specifically like search queries as well as like just what's new. So in general, neural networks are deployed to places like Google, Bing, which is basically dying, but yeah, Google and Bing, and they're used for like to basically get you the search results that you type in into an address bar or something. Um, they're basically just looking over large amounts of uh, PDFs and pages and looking for the exact like search queries and search terms using neural networks and patterns, right? Yeah, and I think a final application that you interact with probably the most out of all of these has to be spell check, right? If we look to like Google Docs or Word, we nowadays we even have an option, right, where we just hit tab and like it autocorrects words for us. It's clearly looking for like patterns of like misspellings and just like comparing it to like the actual spelling of the word using a neural network, and then it just gives us a spell check. It seems like super magical, but it's actually really simple once we dive into a neural network. So I think some important system components within neural networks that we would need inside like a server or something, or some machine or something that would be running a neural network. Or like even before, right? If we go back, like even like an iPad Pro or something, that would be running a neural network to do this. So I'd say some important components, storage. So when we're dealing with things like image segmentation and things, we deal with something called data sets. So in the case of image segmentation, it's just large libraries of images. Like I once worked with an AlexaPath library that was bigger than 150 gigabytes, and it had like over like 3,000 pictures in it of the exact same place with varied lighting and varied conditions. Um, so yeah, storage is key in neural networks, especially if you're trying to go through big amounts of data with your neural network. So having that in the server would be really good. I think another thing that's important is RAM, because RAM is running the program and keeping it up, processing data, um, along with your CPU, right? So the CPU is what's going to run the program actually along with your RAM. And it's basically just going to send the data from like say your data set or some other data point that could be even remote over the internet, right? And it would send data from whatever storage, whether it be network attached or hardware in your computer, to your GPU. So yeah, you want a decently powerful CPU here with a high clock, so over 3 gigahertz at least, with 2 cores minimum, to run something like TensorFlow or even Elastic, as I'm going to show you later on. And yeah, the GPU is basically like the heavy weightlifter here, right? It processes and categorizes data, and it needs a lot of horsepower here. So like Elastic, yeah, you could use your inbuilt like integrated graphics in your Intel laptop, right? But when we're dealing with something like UNet, Keras, or TensorFlow, like what I use in my Alexa Path work, where we're dealing with large data sets that need to be efficiently classified, you need a powerful graphics card here. So at least 20 gigs of VRAM, high clock speeds, over 1800 megahertz. Like you need a lot of teraflops here. Where this is not like simple work. It's not like gaming. Where you just need like VSync and then like some VRAM. Oh my bad. Let me go back to what I was saying about GPUs. Okay, so the GPUs are basically the main component at the end of the day. Like your data set could just be tiny and you could have it on a small amount of storage. Your RAM could just be running the program at a bit of a slower speed. There's not going to be much bottlenecking there, or with the CPU in terms of clock speed, but in terms of cores, yes, because cores actually dictate like how much bandwidth is going to the GPU. Um, so yeah, when we're running something like Elastic, which I want you guys to try at home, yeah, you could use integrated graphics, but when we're using something really powerful and something that needs to be efficient and able to process tons of data like UNet, Keras, or TensorFlow, which are basically one program, you want a very powerful card. So in my case, I use an NVIDIA Titan Black. It's kind of an old card, but it has a good amount of VRAM, it has a decent clock speed, and I have overclocked it. So that came in handy when I was doing work with TensorFlow here. Okay, so I think now it's your turn. Let's go through how you can apply it. In this case, we're going to do some image segmentation. How you can apply like a very base level neural network, something like what you would see in the iPad with handwriting recognition, except we're going to apply this to something else. We're going to apply it to Alzheimer's disease. So yeah, we're going to use Elastic here. Elastic is an open source program. You guys can download free on, I think it's currently in Linux and Windows, but there's probably a Mac version that you could compile or something. Yeah, so let me introduce you to the Elastic interface. So right here, we've got 3 layers in this case. First off, I need to introduce you to our basically data set here. So my data set here was 3 of these histopathologically stained sections that were taken straight from, well, a donor brain that was sectioned using some very precise tools, and then that was histopathologically stained so that we can categorize certain parts of the brain, including these right here, which are called NFTs, neurofibrillary tangles. Those are clears and Alzheimer's. Neurofibrillary tau is a clear protein that indicates Alzheimer's here. So what I did here is basically we would use, give me a second, that's for later. Hold on a second, Zoom is giving me issues today. All right, so when we look over Elastic as an interface, we see here that we have 3 layers. So we first off start off in the image segmentation process with our neural net, Elastic in this case, with a section background. So in this case, this is our section background. These are basically unaffected areas of like a brain section in this case, but you could have it be grass and then these could be like trees or something, right? And then we have 2 layers here. So we have a NFT layer, I told you what NFTs are, and we have a beta amyloid plaque layer. And beta amyloid plaques are basically NFTs on like a grander scale. So you can see here that it's trying to classify it, but later on I'm going to show you how you can make it a bit more precise. So yeah, you have these 3 layers, you assign colors and names to each one of these, and basically just it's kind of like using MS Paint, except it's on like a bigger scale and your computer actually does work. You know what I'm saying? So basically what you want to recognize. So in this case, I want to recognize an NFT, right? So I'm by blue NFT layer here, and I'm simply just going to take my brush from here, right? I brush over about 4 or 5 different components of NFT in this case, and then I simply I leave my input data alone. Input data is the raw image that we input, like the raw like micrograph that I took in this case. And here what you can do, you basically jack the segmentation on both layers for the important layers, so neurofibrillary tau as well as beta amyloid plaques in this case, and you can screw around with the prediction of it and get it dialed. These are generally pretty easy to understand and like takes you about 5 minutes to realize that if you set them like decently precise, you'll get some very good results as I'm about to show you. So let's look at some results that you can get out of Elastic. So first off, this is one brain section. So I started off obviously with our NFT layer, as I told you, blue layer. Simply applied it to a couple of these neurofibrillary tau, and we got this. But as you can see, we're getting mischaracterizations. So we have beta amyloid plaques right there. They're being mischaracterized since we only used 1 layer, and that's how the stain is going to distinguish. But here's the thing. In this case, we actually had lower accuracy, even though we had our settings down. So yeah, as you can see, when I implemented a beta amyloid plaque layer, you can see that there's actually mischaracterizations. So here we have NFT, but here, look at that pink stain. That means clearly that we have mischaracterization. But in this case, we can see a bit more precise. So it's a bit iffy to start off with, but then we go into our second data set. And well, this one has even less spread out NFTs as well as beta amyloid plaques. And you can see once we've implemented blue layer, it seems pretty accurate. It's classifying both though. And obviously, now once we move into our beta amyloid plaque layer, however, using this section, what we did here was we applied more data points. So we used our blue layer to classify more diverse NFTs, as well as our red layer to classify more diverse beta amyloid plaques, because they all range in size and they're very different. And once we ran that, we got these decently precise results. We had a couple of mischaracterizations, but mostly good results here. So this is a neural network that you can apply at home on your consumer hardware that I think would be a great place to start when you're getting into neural networks. Um, and finally, we can just admire these and say,
I use that.
yeah. Now we're going to get a bit more advanced. So I really don't recommend trying this at home unless you're like willing to just like thermal throttle, like melt your laptop, or like you have AWS or some god tier GPU like a Titan RTX 8000 or something. I don't know how that's accessible. So let's look at TensorFlow, UNet, Keras, Python. So as a background description, basically what TensorFlow and Keras are machine learning neural net libraries that go over Python. Now, it's pretty simple to deploy one of these. It's just obviously there's a whole hardware requirement that you have to fulfill here. So when we're dealing with this, I'm going to walk you through the sample script I made for this data set over here, if you remember. Now, we didn't get any raw output from this here, but this is just to show you like the kind of accuracy that you can get with UNet compared to, say, Elastic. So we're going to start off by saying python-m keras. So Python, obviously, this tells our bash system to initiate Python here. We're going to go into keras segmentation train, which is a flag that's going to tell us that we're basically looking to segment images. Then we're going to go to the checkpoints tab. We basically how I set this up is I set up a whole directory structure. So yeah, it's in your best interest if you're using this to set up a directory structure similar to this. So you want to start off with a checkpoints directory that will basically outline kind of what we did in Elastic with like highlighting certain data points that we want. And then there's two data sets you need to work with here. So you'll have a training data set as well as a testing data set. In your training data set, you're gonna have a like sample set of images that are, let's just say, a bit more like spread out and like less complex for the computer to try to identify. But at the same time, you can also make your training data set very hard, which is what I did in this case. I made it a very complex data set. So I ended up actually giving the computer this image instead of this one, where this one was a bit more spread out. So yeah, I give it a harder data set to train itself. So we're training the neural network what it needs to look for, like what data points. So in this case, NFTs and beta amyloid plaques. Now we're going to go down to our test data sets here. So I have, in this case, I had a prep test data set where I had like hundreds more of these section images. Obviously, I'm not allowed to give these to you due to HIPAA laws, but I'm sure you can find large data sets just like this that are publicly available. So you give the computer a harder training set in this case, and then you give it the set that you actually want to identify and notify it as the testing set. So you use the flag val images here and give it the file path to your rep set for testing, as well as you'd have an annotation set with the given marks of the data points, just like we had up here with checkpoints. Except this one is going to be a bit more precise, and you're going to have to use some sort of markup like MS Paint, which I wouldn't really recommend. You probably want to use Paint.net or GIMP for this. to basically do what we did in Elastic, where we marked out NFTs and beta and plaques. We have to mark a lot more here and make sure that the computer knows what it's looking for. Specifically here, this is basically just identifying the resolution of the images. So I gave it 640 by 320 images, 2:1 aspect ratio. Pretty simple. And then I gave this whole thing a model name. So this model name is what the computer is going to spit out and identify as like what you want it to be called. So in this case, I just called it BGG underscore unit. Yeah, and if you guys don't know what epics means how many times the computer is going to run the program. So I gave it 3 epics so that I could have some decent accuracy here. And steps per epic, that means 20, so it's going to go through all of these. That just identifies what, like, how many steps it needs to do. Yeah. So the results of UNet are much more surprising compared to the results of Elastic. So UNet is much more precise. So as I said, I gave it 3 epics, so I told the computer to run it 3 times. So within the first epic, I gave it my training and testing data set. And as you can see, barely a 0.9% accuracy when we first tested within our first epic. This is what the computer is going to spit out in your terminal, by the way. Now we're going to go to here, 2 out of 20. We're going to see that we started to, as we went along, get a 24% accuracy. And then as we continued through the first epic, we got an accuracy of around 50% to end that off. Now, when we came into the second epic, things were a bit better. So we got clearly 20 out of 20 recognized compared to our training and testing sets. So that means the computer over time is learning, right? As we can see with the neural network here. It's thinking like a human and finding patterns over time and just connecting them as we go through. So here we saw 62% accuracy. And then as we continued into our third epic, things got really good, but they started to go on a slight decline. So obviously 20 out of 20 images correctly recognized. However, we saw a 58% accuracy here. So UNet, while it's a bit more accurate compared to Elastic, probably a lot more on some scales compared to the size of data sets you're using, it's really like at this point, like this was on very low end GPU, even for me, like a Titan I was using here, and like GTX Titan. I was using that here, and still I was getting these kinds of results. I'm sure on better hardware, you would definitely get better accuracies here, and you would get quicker speeds. So the thing is here, when you're working with something like even UNet here, you're going to see low amounts of accuracy until you run it multiple times. Yeah, you would have to give your computer multiple epics here, and it would take quite a while for this to go through. So I guess that's all. Unless you all have questions or something. I think generally data science and usage of neural nets in data science is like really pertinent today. And I hope you guys really like this presentation, and I hope you guys go and try out Elastic at home. It's neural networks are like really fun, and you can get pretty hands-on with them. They're not like some crazy hard thing to get to terms with just because Apple tries to make it seem like magic on their iPadOS 14 doesn't mean that it's hard for you to get it started on something like your basic home laptop or desktop. But yeah, I hope you guys definitely go try out neural network, and I hope you guys understand that neural networks are applied all throughout your lives without you even knowing it. So yeah, I think now I'm gonna start taking questions. So anyone wants to go ahead. Okay, so I'm getting some questions in chat. So how large are the nets used for each of the examples? So as I told you before, um, Elastic is a very small scale net. Like I fed Elastic 1 image in that case, like not much of an image. Um, so Elastic is probably, if you're looking to install this on your computer, I don't know if that answers your question, but Elastic is a solid like 4 or 5 gigabytes from what I last remember. But I used this program over 2 years ago, so for all I know, there have been updates, there have been new compilations that have changed things. When you're working with TensorFlow and UNet, you're working with obviously the larger data set sizes, but also now you're working with a much more complex script set. Um, when I was last using TensorFlow and UNet, it was decently big already. Like I had a whole 128 gig SSD full on my AWS instance, and like I was filling up SSDs on my computer even faster. Um, I think generally you want to start with Elastic, but if you're on an AWS instance, I'd say get like 256 gigs just to be safe, especially with data set sizes. And since Elastic is a decent size, but UNet and Keras are gonna be much bigger. So yeah. This comes from Brett Kim. What literature would you recommend aspiring machine learning students to read? I don't generally tell people to read literature. I generally just go off documentation when I'm learning a new programming language, or if I'm learning TensorFlow in this case. But as I showed you before, like if you want to get a basic set going in TensorFlow, like if we just go back here, um, like there's a simple way to do this, to get something like this going. So like I'd say don't really go for literature just yet. But I think I forgot the dude's name, but there's one book written by this French engineer at Google. It's a pretty good book that my dad was reading. So in that book, it talks a lot about system requirements as well as like theory in general. Um, but yeah, if you want to deploy something like this, I would recommend definitely you use Linux, and definitely use Linux with good drivers. So in my case, that's Solus Linux, has the latest kernel. It's a rolling release, has latest drivers. Um, and I think also Pop! OS is a great option for like newcomers into the Linux space. So you could try Pop! OS. I think it's currently 20.04 LTS. And on that, I think there's a single package you can install to get all of these TensorFlow libraries and to try one of these data sets. Um, it's like to apt install TensorMan. Um, yeah. Are there any other questions? All right. Seeing no more questions, so I think I'm just gonna sum up what we've talked about today. So we've talked a lot about specifically how we can apply neural networks on home consumer hardware. Um, I think generally, if you're looking to get into the whole big data space in terms of neural networks and image segmentation, like I have, um, go ahead, and I think we're giving out AWS Educate licenses. So please go ahead and claim that. Get an instance, give it like 256 gigs of storage, 16 gigs of RAM, and like a really powerful GPU, and you'll be off the ground. You can get TensorFlow and stuff installed, and I think you'll have a good experience on that. Or you can build yourself a PC if you're ever so crazy. It's going to cost you a lot of money for that kind of hardware to run TensorFlow and UNet. But I think generally, to sum up, um, neural networks as a whole, we're basically trying to loosely replicate the human brain as close as possible in terms of our pattern recognition skills. This is not like some sort of Google DeepMind here. We're trying to identify basic patterns to get off the ground here with something like TensorFlow and UNet. So I think you guys definitely should get off the ground with something like Elastic and move yourselves into something like UNet and Keras, because once you get into big data and like like when you're on something like Elastic, you have choice. You can use single images. Um, you don't have to be crazy with like the amount of training stuff you provide to your program. But once you get into the whole Keras unit world, it is very, very hard to obtain large data sets. I remember it took me a solid month to even get access from HIPAA and like since I was working with obviously cadavers and given sections that I had to stain and take from them, obviously there was a lot of regulation around that, and like the data sets that I got, I couldn't provide to anyone else, and like they weren't even that large. You know, I was working with, in those cases, very high quality photos with very high resolutions that were only about, I'd say, 800 pictures total. So yeah, in summation, like I know I've said this 2 times already, but I'm gonna say it again. Get off the ground with Elastic. Um, Use it to find patterns on like 1 or 2 images. It can be anything, like a cityscape. It could be a valley or something, or you could just identify trees versus rock. Like you can give it a picture of the Grand Canyon and just tell it look for rock and look for trees. But once you get bored of that, you have access to small variety, but a variety, there be it, of publicly available data sets that you could download onto an AWS instance, create your own file structure as I showed you, and just like make it simple for yourself um, to get into big data and neural networks and find patterns in large data sets. So yeah, are there any more questions at all? Okay, so for you guys, thank you all for coming. I know it's a very small number of you who decided to attend this. Um, I hope you enjoyed it, and I hope you do go try Elastic. I'm going to say this over and over again, but you'll be amazed by what your like own little like cheap little laptop can do, right? Like even something with a Celeron can run Elastic and give you some pretty nice results. So yeah, I will in the Slack drop you guys some links to some of the data sets that I have used. I'll drop you a link to some of the operating systems that I talked about, so Solus and Pop! OS. If you have a PC, if you have some PC hardware that you're willing to put it on, that you're willing to wipe and install some proper drivers on, as well to some guides and some books. I'll link you, forgot the dude's name, but I will link you to that book about the Google engineer who actually created TensorFlow and who actually goes over documentation and things, theory. Anything else I need to link to? Oh yeah, if I can, I will leave some instructions on how to create some basic directory structure as I showed you, so you can have some pretty simple directories when you're working with an AWS instance to run some trading and testing and get some pretty good results. So yeah, I hope you all enjoy. I hope you do try this out, and definitely like make use of some computers if you have something like lying around your house. Give Elastic a try, and if you're really into neural nets and finding patterns with a computer, go into Keras and Unit. Yeah, that's all. Thank you guys so much. I'm going to leave now.